Hey, this is Steve, the lead developer of Epicycle from Gen Astro. In this video, I'm going to cover the AstroEpochs package. AstroEpochs is a package for defining time and performing conversions between different time scales and time formats. I'm going to give a primer on time scales and formats, then I'm going to go over the time struct. Then we will learn how to create time structs, and then finally how to convert time structs to different formats and scales. Before we jump in, I want to give some acknowledgments. AstroEpochs uses tempo.jl under the hood for the arithmetic and the time conversions, and the interface is designed after astropy.time, and the mathematics are tested against astropy.time. AstroEpochs supports a number of time scales. The most common time scale that we use every day is the Universal Coordinated Time. This is the time that's on your watch. It also supports relativistic time scales. Barycentric dynamical time is used in solar system ephemerides and often used for interplanetary modeling. It's a time scale reference to the solar system barycenter. The terrestrial time is a relativistic time scale referenced to Earth. And then finally, one of the ones we use often is TAI. It's an atomic time based on the oscillations of the cesium atom. There are a number of time formats supported, including the full Julian date, precision Julian date, which uses two floats to represent the Julian day, a day number and a fraction of day. Best practice here is to keep the day number to an integer or within a half day, and keep the fraction of the Julian day less than 1. And this allows bookkeeping time to better than a nanosecond precision. Then there's the modified Julian date, and there's a string format using the ISO time. The time struct in AstroEpochs is the software element that's used to store and convert time. It uses a split Julian date representation to maintain numerical accuracy at sub-nanosecond precision. Under the hood, it stores the date in two floats. What's JD1 is the primary component, which is preferably an integer portion of the day. We'll come back to that. And JD2 is the fractional part of the day. The time scale is a Julia tag struct. You can see the syntax here, but we're going to come back to it. And finally, the time format. So the time struct has 4 data members under the hood. Some guidelines for using the time struct. In general, you want to keep the magnitude of JD2 small, less than 1, to make sure you can maintain nanosecond precision if you need it. And use JD1 as the integer portion of the day, or importantly, don't have a lot of significant figures in the JD1 portion of the date. And now let's look at how to define some time and convert them into software. Now let's use the AstroEpochs package. Pull up a Visual Studio Editor or some other editor where Julia is installed and Epicycle is installed. And we're using AstroEpochs to load the module. And we're going to start with setting time in different scales. I'm a painful typer. I'm going to do a lot of copying and pasting here, so you don't have to watch me type. But let's start by setting a time in TAI. Type this first one. Here we setting a time, so we call the time struct. We'll set the time and modify Julian date initially, and we'll set it in the TAI scale. So the syntax here is time value, time scale, and then time format, and we'll set it in modified Julian date. And enter the time. So here we've created a basic time struct. Let's create some times in different time scales. I'm going to copy and paste here so we don't use video time with me typing. Here I'm going to create a time in TDB. This is barycentric dynamical time, still using the modified Julian date format. And we could do the same thing. We'll create some structs here in TCB, still using modified Julian date. And there's currently 5 time scales supported. I'll stop there, and as the system grows and more time scales are supported, you can see all supported time scales by looking at the subtypes of the abstract time format in the AstroEpochs package. So here, as of the date of this video, oops, that was time format and not time scale. Here we have TAI, TCB, TCG, TDB, TT, and UTC are the current supported timescales. Now let's look at how to enter a time struct in different time formats. Here, let's enter a time struct in a full Julian date. And the first value is the time value. I'm going to copy and paste the Julian date value here. We'll set it in the TT time scale, and here we specify that this is a full Julian date. So we've created a time struct using a full Julian date. I already used modified Julian date example when we were setting time scale, so I'm not going to do that one again. Here's the way you define a string date format using the ISO time format. So here we have year, month, day, then hours, minutes, seconds, and fraction of seconds. You can add more significant figures here, and the system will store these under the hood. Quick comment that the pretty print output doesn't show precision all the way down to nanoseconds. It is stored under the hood, but it gets to be a lot of data printed to the screen. Finally, if you want to define time to nanosecond precision using two real or float formats, you can provide a day number and then a fraction of day. And here we've created a precision Julian date using two floats. Finally, as the system grows and it supports more formats, you can see which formats are supported by looking at the subtypes of the abstract time format struct in the AstroEpochs package. So here you can see that currently the three formats supported are ISO time, Julian date, and modified Julian date. Now let's look at how to convert time between time scales. We've set time in different time scales, different time formats, and now we want to convert between them. So let's make sure that in case you haven't defined the time precisely the way I have, we're going to have a time struct defined as T_TAI. Now let's say we want to convert that to terrestrial time. So we're going to specify that we want to take the TAI time and then we're going to convert it to terrestrial time. The syntax in Julia is that struct names are uppercase and struct field names are lowercase. So this is standard Julia convention here. And this returned a new time struct. So now you can see the time value is actually different because the time in TAI and TT are not equivalent. This did the conversion. Similarly, if I wanted to take my UTC time struct that we created earlier, created here again just to make sure you have it locally, you follow this. Now we'll say we want to take the time where we defined in UTC and convert it to TDB. So here it returned a new time struct where it took our time that was input in UTC but converted it to TDB. You can follow the same pattern to convert between any time structs, input time scale to any other time scale. The approach to convert between time formats is similar syntactically. Here I'm going to create a new time, just call it T. There is a subtle difference. Let's say we want to convert this time, which was input in Julian date, but we want to see it in modified Julian date. So here I'll just type t.mjd, and here it's returned the modified Julian date value. Similarly, if I want to see it in the ISO time format, I can just type t.iso t. This is just returning a value. So when you convert the time scale, it is returning a new struct because you're actually changing the time values themselves. When you're asking for a new format, you're just taking the time and asking it to put it into a desired format. So you don't get a new struct here. Similarly, if you want to see the precision date components, you can type t.jd1. This will return the Julian date day number, and then if you wanted to see the fraction of day, just type t.jd2, and here you can see the full. Here we only defined the date with a few significant figures. If we defined it with more sig figs, you'd see all of them. So time arithmetic, the system handles overloaded time arithmetic. So let's define a time t1 here. Now let's say we wanted to add one day to this time. All I have to do is say, all right, my new time is T2. I'll just say it's equal to T1 plus 1 day. And forgot the plus operator. And now we have a new time that's been incremented by a day. You can subtract times, and that's overloaded. So let's say we wanted to know what the time difference is between two times. So here we'll subtract T2, subtract T1 from T2. And here you can see it's 1 day because that's what we added to T1. So that covers the AstroEpochs module. If you have more questions, if you go to our GitHub account at GenAstro Epicycle, you can see all of the documentation for Epicycle, and the full documentation for AstroEpochs is available right here. Covers everything we covered in video form for those who like to go through and read documentation. It's all there. So thanks for watching.